Download this code and get free GPT-4o from codegive.com, link in the description below. Java RMI, Remote Method Invocation, can be a powerful tool for remote communication between Java applications. However, it can also be vulnerable to various security issues if not properly configured. This tutorial aims to provide an overview of how vulnerabilities in Java RMI can be exploited, along with a simple code example. ###disclaimer. This tutorial is for educational purposes only. Always seek permission before testing or exploiting vulnerabilities in any system. Unauthorized access to systems is illegal and unethical. #Understanding Java RMI. Java RMI allows Java objects to communicate with each other across a network. It enables method calls on a remote object as if they were local. However, if the RMI server is not properly secured, it can be susceptible to various attacks, including remote code execution. #Common vulnerabilities. 1. Insecure deserialization. If an RMI server deserializes untrusted data, it may lead to arbitrary code execution. 2. Weak security policies. Java applications often run with insufficient security policies, allowing untrusted code to execute. 3. Misconfiguration. Using default configurations may expose RMI services to the public internet without proper authentication. #Setting up a simple RMI server and client. Below is a basic example of a vulnerable Java RMI server and client to demonstrate an exploit. #Step 1. Create the RMI interface. Step 2. Implement the RMI server. Step 3. Create the RMI server main class. Step 4. Create the RMI client. Running the example. 1. Compile the classes. 2. Start the RMI server. 3. In another terminal, run the RMI client. Exploitation of the vulnerability. The execute command method in the server implementation allows remote execution of arbitrary commands. An attacker can exploit this by sending malicious commands through the RMI client to execute arbitrary code on the server. For example, an attacker could modify the RMI client to execute. Mitigation strategies. 1. Use security managers. Implement a security manager to restrict permissions for untrusted code. 2. Authentication and encryption. Use proper authentication mechanisms and encrypt communications. 3. Input validation. Validate and sanitize all inputs to prevent command injection. 4. Limit exposure. Only expose RMI services to trusted clients and use firewalls to restrict access. Conclusion. Java RMI can be a powerful tool, but it can also present serious security risks if not properly secured. Understanding these vulnerabilities and implementing proper security measures is crucial to safeguarding your RMI applications. Always conduct security assessments and stay updated with the latest security practices.